Hello, we are going to talk about experiments today. Experimental research is most appropriate research for testing causal hypotheses. True experiments must have at least three things. Number one, two groups. One is the experimental group, one is a control group. Number two, variation in independent variable before assessment of change in the dependent variable. In this case, we are manipulating the independent variable to see a change in the dependent variable. Number three, random assignment to the two or more comparison groups. Sometimes we call this randomization process. Here's a true experiment. Sometimes we call the classical experimental design. First, we have this group 1. We have E referred to experimental group. R means randomization. Group 2, control group, and R means randomization. O1 means observation 1, or we call that pre-test. O2 is the post-test, it's observation 2. So we can see that how these treatment works after how this observation 2 or the post-test changes after the treatment. Observation 3 is the pre-test for control group. Observation 4 is the post-test, and the control group without the treatment, here. Okay. So we are talking about, in terms of treatment, is a political ads to show how the political knowledge. So what we are trying to say, or the hypothesis, is that the ads will increase, political ads will increase the political knowledge. Okay. So let's say that is political knowledge 1 referred to no knowledge, and 10 means high knowledge. So we want to see whether or not the treatment or the political advertisement can increase the political knowledge. Let's assume that we do everything randomization, so this two mean between the two groups will be the same. So one is a 5, mean is 5. The other one is a 5. The treatment group, assuming that the political ad works, so the mean gets up, which is become 8. But no treatment, and the mean remain the same, 5. So then we can say that there is a 3 points increase for the treatment. So then we can say that yes, hypothesis is supported by the treatment group. So this is a true experiment or classical design. The second is the post-test only design. Same thing, we have group 1 and group 2. Group 1 is experimental group. Group 2 is control group. Randomization. So everyone is randomly assigned into two conditions. Group 1 has treatment, which is the experimental group, and group 2 has no treatment, just have post-test only. And assuming that everyone is a randomization, so the mean goes up to 8. So we have 3 points kind of plus in the treatment group, and the mean here is still remain the same, it's a 5. So then we can say yes. So hypothesis is political kind of ad works, and so it does increase by 3 points here based on that. Okay. So this is the post-test only design. So in this case, there's no pre-test. There's no pre-test here, and there's no pre-test here. So therefore, it's a post-test only design. And here we have this group 1. We have this true experimental design here, and the post-test only design here. So when we combine the two designs together, we call that Solomon four-group design. The reason this Solomon four-group design is more effective because you can compare this experimental group with this experimental group to see how this pre-test effect have any impact. We can also compare this control group to see any kind of pre-test effect. We can also compare the treatment effect to see whether or not the treatment have any kind of impact. And then we can do other comparison as well. And so this is Solomon four-group design, give us more options to do comparison. The downside for this Solomon four-group design is that you need more people. Usually one condition is 15 people and another 15 people. So another 15 people, another 15 people. So we are talking about 60 people together. So this definitely needs more resources. Here is the exhibit which shows us how this random sampling differing from the randomization. Random sampling used in survey methodology, we randomly select people, and randomization is a randomly assign people into different conditions, like toss coin. So that is difference. So random sampling used in survey methodology, randomization or random assignment is used in experimental design. Quasi-experimental design is the experiment without randomization. So there are several types of design, like non-equivalent control group design, before and after designs. And within this before and after design, there's also some other specific examples. Summary for causality in quasi-experiment, and we have some detailed discussion. I hope you can have time to read this. Validity in experiment. Like any research design, experimental designs must be evaluated in terms of their ability to yield valid conclusions. True experiments are particularly well suited to producing valid conclusions about causality, but they are likely to fare less well in achieving generalizability. So everything has two sides. When experiment is good at internal validity, which is the causality, and they are weak in generalizability. Quasi-experiments may provide more generalizable results than true experiments, but are more prone to problems of internal validity. Measurement validity also a concern, but experimental design does not in itself offer any special tools or particular advantages or disadvantages in measurement. An experiment's ability to yield a valid conclusion about causal effect is determined by the comparability of its experimental and control comparison groups. First, of course, a comparison group must be created. Second, this comparison group must be so similar to the experimental group or groups that it shows what experimental group would be like if it had not received the experimental treatment, if the independent variable had not varied. There are several kind of sources of internal invalidity, like selection biases, endogenous change, history effects, contamination, treatment, and misidentification, which are very important sources for us to read later on. True experiments play two critical roles in social science research. First, they are the best research design for testing nomothetic causal hypotheses. Second, true experiments also provide a comparison point for evaluating the ability of other research designs to achieve causally valid results. Although the true experiments are good, but there are several reasons they cannot be used in various investigations due to social limitation and the scope of